Hello everyone. So this time we will now be discussing trigonometric substitution. So this is part of the integral calculus course wherein yung mga algebraic expressions natin sa integrands natin we transform into their corresponding trigonometric functions. So we will be looking at three cases for this particular type of substitution. So we have three cases. So yung first case natin, when yung integrand natin, it has the form a squared minus u squared. Wherein si a is a constant or a perfect square constant and si u squared is a perfect square function of x. So when we recognize this pattern sa integrand natin, we will use the substitution u is equal to a sine theta. Now, when we have determined itong substitution na u is equal to a sine theta, we can draw its corresponding triangle by using the sine function. When we substitute or when we get the corresponding sine function of case 1, we have sine theta is equal to u all over a, where we can see that u is the opposite side of the angle theta and a is the hypotenuse of the right triangle. So from case 1, we can draw this particular triangle. And then all the substitution, we will refer to this particular triangle. So we have u as our opposite side, we have a as our hypotenuse, and by Pythagorean theorem, we will get the value of this particular side. So that is for case 1. Now for case 2 naman, when our integrand contains the form u squared plus a squared, where u is a function of x and a squared is a perfect square constant. Now when we recognize this particular form sa ating integrand, we can use the substitution u is equal to a tangent theta, where u is yung function natin and a is yung constant natin. And then, after determining itong particular substitution na to from the tangent function, tangent theta, that is equal to u is our numerator, tapos a will be our denominator. So from this equation class, we can see that u is yung opposite side and a is yung adjacent side from the concept of SOHCAHTOA. Now, when we have determined itong substitution na to, u is equal to a tangent theta, from this concept, tangent theta is equal to u all over a, we can determine or we can draw yung corresponding triangle na ito. So, we have, from the tangent function, we have u as our opposite, so we have u as our opposite, and then we have a as yung adjacent side, so we have a as your adjacent side. And by concept of Pythagorean theorem, we can get the value of the hypotenuse side or the longest side of the right triangle. So that is for case 2. And then for case 3, when our integrand contains the form u squared minus a squared, wherein u is a function of x and a is a constant, when we have this particular form sa ating integrand, we use the substitution u is equal to a secant theta, where u is a function of x and a is a constant. Now, after we have determined yung corresponding substitution natin na u is equal to a secant theta, we will now use this substitution to derive or to draw this triangle right here. And then yung mga values ni u, yung values ni u squared minus a squared, we will be using these values for our substitution sa ating integrand. So from the substitution equation u is equal to a secant theta, we can rewrite this as secant theta is equal to u all over a. And then getting the reciprocal of two equations or two sides, the reciprocal of secant is cosine theta, and then the reciprocal of u all over a is a all over u. So this will now be yung magiging sides ng triangle natin, where from the SOHCAHTOA theorem, we have a as your adjacent side and u as yung hypotenuse natin. So dito sa triangle natin, we have a as yung adjacent side natin and then yung u as our hypotenuse. And then this side right here, we can derive from the concept of Pythagorean theorem. So these are yung mga patterns na kailangan nating ma-recognize sa ating mga integrands to use trigonometric substitution. And then when we have determined if it falls under case 1, case 2, and then case 3, we draw yung corresponding triangles na gagamitin natin for our substitutions. So that's for our introduction. Let us now proceed to the sample problems. Okay, so let us now start to answer practice problem number 1. You have evaluate the integral of x dx all over square root of 4 minus x squared. Now at first observation, we can see 4 minus x squared. So we have 4 as a perfect square constant minus x squared, which is a perfect square function of x. And taking a as the constant and u as the function of x, we can conclude that this is your a squared. And then we have minus, we have yung u squared. And this particular form resembles yung sa case 1 natin. So our substitution will be u is equal to a sine theta. So now we have established that we need to simply determine the values of a and the values of u. So if a squared is equal to 4, therefore getting the square root, so we have a is equal to 2. And likewise for u squared, if u squared is equal to x squared, which is shown here, if u squared is equal to x squared, then getting the square root of both sides, we get u is equal to x. So these are the corresponding values for a and u that we will use in the trigo substitution. U is equal to a sine theta. So writing u is equal to a sine theta, we know that u is equal to x. So we have x equals, and then a is equal to 2. So we have 2 sine theta. So this is now our trigo substitution for x in terms of theta. And then from this trigo substitution, we can equate yung trigo function natin. So we have sine theta is equal to si 2, ilagay natin sa denominator ni x. So we have x all over 2. So we now have sine theta is equal to x over 2. And then from that, we draw the corresponding triangle. So we can get the substitution values for each part of our equation. So we have a sine function from the concept of SOHCAHTOA. The numerator will be our opposite side, and then our denominator will be the hypotenuse side. So taking this as theta, so therefore we have yung opposite side, we have x, and then yung hypotenuse side, we have 2. And by Pythagorean theorem, we can get the value of this side right here, which is from Pythagorean theorem, we have hypotenuse squared minus the square of the other leg. So we have x squared. And simplifying, we will get square root of 4 minus x squared. Now this is the triangle that we will be referring with when we want to substitute the x variables in terms of theta. So going back to our substitution, we have x equals 2 sine theta. So this will now be our substitution for the x variable right here. We need a substitution value for the x now in terms of theta. So in order to get dx, we will get the differential of x. So getting the differential of x, so we have differential x equals the constant 2 and then multiplied by the derivative of sine theta, which is cosine theta. And then since it is differential, we differentiated with respect to theta, so we should add a differential theta at the end. So we have now a substitution factor for x and dx. All that's left is to get a substitution value for square root of 4 minus x squared. So in order to do so, we will refer back to our triangle right here. We will equate square root of 4 minus x squared with theta and the constant 2. So relating this side and theta and the hypotenuse is the cosine function from the concept of SOHCAHTOA. So cosine theta is equal to the adjacent side, which is square root of 4 minus x squared all over hypotenuse side, which is 2. And then rearranging the equation, we have square root of 4 minus x squared, that is equal to 2 cosine theta. So this will now be our substitution factors for all the x variables in our original integrals. We have a substitution for x in terms of theta. We now have a substitution for dx in terms of theta. And we also have a substitution for square root of 4 minus x squared in terms of theta. All that's left to do is to rewrite the equation. Let's rewrite the integral. So we have the integral now of x dx all over square root of 4 minus x squared, that is equal to integral of what is the value of x in terms of theta, that is 2 sine theta. So we have 2 sine theta, and then differential x is equal to 2 cosine theta d theta. So we write 2 cosine theta d theta all over the equivalent of 4 minus x squared in terms of theta, that is this equation right here. So we have 2 cosine theta. And it's just a matter of simplification. There will be factors that will be cancelling each other out. So we have 2 cosine theta at the numerator and 2 cosine theta at the denominator. So simplifying further, our integral will be reduced to integral of 2 sine theta d theta. Now we can integrate simply. So the integral of 2 sine theta, so the constant will go out of the integral, and the integral of sine theta, that is equal to negative cosine theta. And then at the end, we add the constant of integration plus c. So this is now our integral. We have 2 negative cosine theta plus c. Now, since the original function that we integrated is in terms of x, and this integral right here is in terms of theta, we still need to transform this integral into its original variable x. So in order to do so, we will get an equation for cosine theta in terms of x. And that equation will come from the substitution that we used earlier. We have cosine theta is equal to square root of 4 minus x squared all over 2. So substituting this value, we will get the negative sign will come in front. So we have negative 2, and then cosine theta is equal to square root of 4 minus x squared all over 2. And then we have the constant of integration plus c. And the 2 will cancel each other out. So we have cancel. Therefore, our final integral will be equal to negative square root of 4 minus x squared plus c. This is now our final answer. So as a recap of practice problem number 1, so we are to evaluate the integral of x dx all over square root of 4 minus x squared. So first thing to do is we should recognize which case does it fall to. So in our integrand, we have 4, which is a perfect square constant, and then negative x squared, which is a perfect square function of x. So 4 will be our a squared minus x squared will be our u squared. So this clearly falls under case number 1. So our substitution for case number 1 is equal to u equals a sine theta. Now we need to determine the value of u and the value of a. So if a squared is equal to 4, getting the square root of both sides, we get a is equal to 2. And if u squared is equal to x, therefore getting the square root of both sides, we get u is equal to x. So having a value for a and u, we substitute simply sa substitution natin. So we have u is equal to a sine theta, u is equal to x, a is equal to 2. Now to draw the corresponding right triangle for x equals 2 sine theta, we simply rearrange this equation to get an equation for sine theta. So dividing both sides by 2, so we got sine theta is equal to x all over 2. And from the concept of SOHCAHTOA, we know that sine theta is equal to opposite all over hypotenuse. So this x right here will be the opposite side of the right triangle, and 2 will be the hypotenuse side of the right triangle. So if this is theta, by Pythagorean theorem, this side right here is equal to the square root of 2 squared minus x squared. And then simply simplifying, so we have 4 minus x squared. So this side right here is equal to square root of 4 minus x squared. So that is our right triangle. So next, the goal of trigo substitution is to replace all the x variables in our original function and convert it into another variable, theta. So we now have x in terms of theta, that is 2 sine theta. We need to find an equivalent of differential x in terms of theta. So from the x equation, we get the differential. So differential x is equal to constant derivative, and since we differentiated with respect to theta, we write d theta at the end. So this is now our substitution for differential x. All that's left is to find a substitution factor for square root of 4 minus x squared. In order to find the substitution for our denominator, we return to the right triangle that we have constructed earlier. So if this side right here is equal to square root of 4 minus x squared, we need to relate this side right here with theta and the constant 2. We do not need to relate this with the variable x, since we are replacing all x variables from our equation into the variable theta. So we relate this side right here with theta and the constant 2. So 2 is the hypotenuse, this is the adjacent side. So the relationship between the two is cosine. So cosine theta is equal to square root of 4 minus x squared all over 2, with square root of 4 minus x squared as the adjacent side and 2 as the hypotenuse. And then we simply replace all the x variables in our integrand with the corresponding trigonometric functions. So we have for x, that is 2 sine theta. For differential x, that is 2 cosine theta d theta. And then for square root of 4 minus x squared, that is 2 cosine theta. Cancel everything that can be cancelled. So our integral will be integral of 2 sine theta d theta. And then integrating, so yung constant pwede nating ilabas sa ating integral sign. And then the integral of side is negative cosine theta plus c. So this is now our integral in terms of theta. We still need to convert this into its corresponding x variables. Since the original function that we need to integrate is in terms of x, so our answer should also be in terms of x. So cosine theta from our substitutions, cosine theta is equal to square root of 4 minus x squared all over 2. So we replace cosine theta with this value right here. So cosine theta becomes square root of 4 minus x squared all over 2. So the 2's will cancel each other out. So we are left with the answer negative square root of 4 minus x squared plus c. So this is now the answer to practice problem number 1.